widely everywhere across the globe. Hope my screen is visible.
Yeah. Visible.
Perfect. So what we are going to talk about today is very simple thing. VLANs. I'm considering many people know about it. I'm not worried, or I won't be really wondering, but still we have to build a pace on the how I'll be teaching, whether that pace is comfortable with you. Are you comfortable with the explaining logics and all those things? That's my simplest topic. Tell me, what are VLANs? In simple word, virtual LAN identifier. Correct?
Yeah.
Now, let's go bit to the history part before even considering the fact that there were no VLANs, maybe a smaller topology. Connected to something like, doesn't matter how we are connected, but everywhere you are connected to all the switches, switch 1, 2, 3, 4, 5, 6, 7, and then you had a different set of machines connected to everywhere. Now tell me what would happen if this machine, which is PC1, would generate any kind of broadcast. In simple words, what exactly would happen? A broadcast would reach out to switch 4. Switch 4 would pass it on to switch 1, switch 2, switch 3. I am not talking about any concepts from STP or all those perspective. We are only focused on a frame, or not even a switch. Before switch, there was a concept of bridge, which ideally what supposed to do, they used to receive a broadcast stream and they used to advertise it on or broadcast it on all the ports except the port where you used to receive it. Everyone is aware about this concept? Okay, I'm considering that as yes. Now, yeah. Now what would happen? Eventually switch 1 will do the same thing. It receives something on one of its port. It will broadcast it to other of the to other ports. Now, what exactly it shows you from this specific logic? You are receiving something on one of the port and you are forwarding it to all other ports. Correct? Now, this concept is basically called as broadcast domain. Correct? So eventually, before the VLAN as a concept, all the ports of the switches were a part of same broadcast domain. Have you understood what exactly is a broadcast domain?
Sir, can you repeat it again?
Yeah. So what would happen on switch? Let's say I'll simplify the diagram.
Okay.
Let's say this is one switch. Okay. It is having 4 machines connected. In simple words, this is one machine, second machine, third machine, fourth machine.
Sir, 4 end devices.
4 end devices. When I say
Yeah,
machine, it means end host, end PCs,
Yeah.
anything. There is a broadcast which is getting received from end device 1. It is landing on switch 1. What switch 1 will do? Ideally, if it is a broadcast, it will forward it everywhere to all the ports except the port from where it has received it. Is it right? Have you understood now?
Yeah, understood.
Yeah. Now this is what you called. So what exactly it shows? This interface, this interface, this interface, and this interface. All 4 interfaces are a part of same broadcast domain. Is it understood now?
Yes, sir. Understood.
Now, what is the problem with same broadcast domain? Is there any problem if you have a same broadcast domain?
There could be a collision of frames.
There could be
Collision of frames.
You're saying people are not able to hear. Can you hear me? Hello,
Yes, sir.
Latif, Chanakya.
Yeah, it's you're audible.
So for people from chat, I believe you have to join it again. Latif and B Moa. You people have to rejoin the session maybe. Oh, they have not joined the audio, I believe. Let me just reply quickly. Okay, let's continue. Now, what is the problem with having a same broadcast domain? A frame which ideally maybe switch this end host machine or PC1 created, maybe it was not even supposed to be sent to PC3 and PC4. It was only supposed to be sent to PC2. But because you are a part of the same broadcast domain, you were receiving the frames which are not even required. Frames received when it is not required. Now, is this a problem? If you are receiving a message which is not even expected to be received by you, you will get irritated. Same thing used to happen with PC3 and PC4. That's where the whole concept of VLAN was introduced. So VLAN, what VLAN will help you? It will basically help you to achieve the logical separation of broadcast domain. Pramod, can you hear me? Why people are facing the problem, I'm not sure, but many people can hear. Pramod, just join the audio. B Moa, now can you hear me? Perfect. Okay. Now, what exactly VLAN will do? It will help you to create a logical separation of broadcast domain. It means what will happen? First of all, what is a VLAN? VLAN is, in simple words, VLAN is nothing but a number, correct? Further detail about what are the number, what is the total number of numbers supported, we will talk about it. But what you will do, a specific interface will be part of, let's say, VLAN 10. Another interface here will be part of VLAN 10. And let's say this interface is a part of VLAN 20, and this interface is a part of VLAN 20. So anything which is generated by switch 1 will only go to switch 3. It will never go to switch 2 and switch 4. Why? Because logically you have separated them in two different broadcast domains.
Sir, please repeat it.
Okay, so what is a VLAN? In simple words, VLAN is just a numbering system. Okay, or in simple words, you can say that it is nothing but a numbering system which is starting from 0 to 4095, and you can create the VLAN numbers. We can say VLAN 10, VLAN 20, VLAN 30, VLAN 40. And you are assigning one interface into a specific VLAN. So you are giving an identity to that specific interface that it is a part of VLAN. Is it clear till now?
Yeah.
Now what will happen? Let's consider this port. Maybe I will give the name to this port. Let's say this is port number 0. This is port number 1. This is port number 2, and this is port number 3. Now we will consider port number 0 and port number 2 are part of VLAN 10, and port number 1 and port number 3 are part of VLAN 20. Now what will happen? You have created two different logical broadcast domain, correct?
Correct, sir.
Is everyone clear about the stream and you are able to understand it now?
Yeah, I understand.
Yes, sir.
Now what will happen? Anything which is originated by PC1 will never go to broadcast domain of VLAN 20, it will only talk in VLAN 10.
VLAN 10. Yeah.
Yeah. So that is a basic use case of having the VLAN by reducing your broadcast domain. So what you will do, if your switch is having a 24 ports, and if these 24 ports are, let's say, divided into 4 VLANs, I mean 6 ports into one VLAN, then you have created how many logical broadcast domains? VLAN number, let's say VLAN name is 10 or VLAN number is 10, 6 ports in VLAN 10, another 6 port in VLAN 20, another 6 port in VLAN 30, and another 6 ports in VLAN 40. So what will happen? You have created 4 different logical domains, logical broadcast domains. Any kind of doubt?
No doubt, sir.
All good?
Yeah.
All good, sir.
Okay. Latif, you have not joined the audio.
Sumit,
Go on.
looking at the topology means, as you said, there would be 4 domain.
Hmm?
But if we are transferring traffic on 4 different VLAN, until and unless it is defined as access or trunk.
I have not introduced you to the concept of access and trunk yet. We are going step by step. As of now, our focus is only on VLAN.
Okay.
Okay. Let me introduce you to access. Let's go step by step. I am considering, even if you know the stuff,
Okay.
rest of the people.
Okay.
Okay. I believe everything is good now. Moving ahead. Now, let's do a quick summary. What is the usage of VLAN?
Reduce the broadcast domain.
Yes. Reduce the broadcast domain. Now, for sure, you must have read this example, simplest example, that HR will be part of one VLAN, marketing people will be part of another VLAN, sales will be part of another VLAN. Have you done this? CCNP book always talks about this, correct? That's not a reality.
Yes, sir.
We never segregate the users on the basis of in which department they are working. We always segregate the VLANs in what type of consumption they are doing. When I say consumption, it means whether they are consuming data, or they are part of voice, or they are part of CCTV, or they are part of printers, or they are part of wireless. You can say IoT devices. You can even talk about it from, what am I missing? That RFID cards. So this is a real use case example. So what you will do, data maybe will be allocated to VLAN 10, 20. I'm just picking up random numbers. Voice will be allocated with VLAN 30, CCTV will be allocated with VLAN 40, printers will be allocated with VLAN 50, 60, 70, 80, and so on. It goes on and on. But this is how the real segregation of users are done, from what kind of services they will be using. Can you please turn up the mic? Mic is on. I'm not sure what is the problem. Rest people are able to hear. Okay. Now, apart from this, what else will be the usage of VLAN?
I think we can say like increase security feature or something.
We can say that, because when you segregate them on terms of VLAN, then you can control on who will be talking to whom. So security is just one aspect. Maybe I want to see that few users from data should only be able to do the printing, not all users. So that can be done when you do the logical segregation. But this ideally is done at layer 3. This ideally is not done at layer 2 of the OSI reference model. So one of the aspect of that is security. Up to certain level, not full level.
It is also reduce the network traffic.
Yes. So basically, which is reduce the broadcast, not domain. Domain is broadcast traffic, I would say. Domain was not the right word. Another.
Sorry to interrupt.
Go on.
Nabi here.
Yeah.
I said, yeah, small clarification.
Yeah.
In my office now, every day L2 persons, I'm working as L1. Okay. Two persons mainly using this observation VLAN, something mismatching, configuration mismatching, something using this. Now my doubt is clarified. You give an example now, data, voice, CCTV, printers. I think mismatching nothing but they have connected to other device. Correct? Huh?
Mismatch in terms of specific interface which was a part of a different VLAN.
Okay.
Is that kind of mismatch what you are talking? Mismatch could be a number of types.
Okay.
Okay. So mismatch would be
yeah.
Mismatch would be, let's say this is a printer. Let's assume
Okay.
this. And this is your switch interface where you are connecting it.
Okay.
Now the configuration of the specific port ideally is, I have not explained you about access port or trunk port or anything, but ideally the expectation was printer was supposed to be part of VLAN 50, right?
Okay.
But instead of VLAN 50, maybe it was configured in VLAN 20. So this is a mismatch, interface or port level mismatch. So totally depends what kind of mismatch is there.
Okay. Due to this, what happened if suppose mismatch now? So
communication may not occur.
Communication. Exactly.
Printer may be not getting IP address. Maybe printer is so what will happen? A printer will have a, let's say, DNS. I don't want to go into the much technicalities, but maybe printing services will not work because IP is not working.
Okay. As per my observation in my office, we are communicating to customers. Customer mail to our L2 persons link was down. Due to this, I think mismatching. Due to this, link was down.
No, link could be down because of a speed and duplex. That is altogether a different speed duplex mismatch. That is not related to VLAN.
Okay.
Okay. We will talk about it later on, speed and duplex things.
Okay.
Yeah. Now, with respect to usage of VLAN, you can also do user segregation. User segregation in terms of user, or I would say, won't say user, I would say services segregation. See, data is one kind of service what you are using. Voice is another kind of service what you are using. CCTV is another service. That's where you are doing it. Now, the question, can we isolate intercommunication within a particular VLAN? Depends on topology, I would say. Much possible by some kind of doing the filtering and putting it on port base or MAC base access list can be configured to achieve this behavior. Now, moving to the next topic. Till now, any kind of doubts?
No.
So what about the separation of intercommunication?
Go on one by one. Feel free to ask. Okay, I'm considering no question. Next topic, by default, when you power on a new switch, let's say this is a new switch what you power on, and let's say maybe there are 8 ports in the switch. Will they be part of any broadcast domain? What do you think?
When a switch is powered on, it will be a part of broadcast domain.
Yeah, will they be part of any? Will that switch be part of any broadcast domain?
Yes.
Yeah, and that broadcast domain is nothing but your VLAN.
VLAN 1.
Yeah. Now let me go back to the technicalities of VLANs. Now, what is VLAN? Is nothing but a number, and it is maximum of 12 bits. So if I say it is 12 bits, how many maximum VLANs you can configure? Or what is the maximum value you can achieve, or how exactly are maximum VLAN supported?
4096.
Yeah, so 2 raised to 12, if we talk about it, which is equal to 4096. Now, this is what maximum VLANs what you can configure, right? Now, how are they divided? Any idea? Let's talk about reserve VLANs first. This 4096, ideally computers don't start their numbering from 1. Ideally computers start the numbering from 0. So the range is 0 to 4095. This is how it is supporting 4096 in total. Okay. Now, what are the reserve VLANs? 0, 4095, 1002 to 1005. These are reserve VLANs. It means they are not used anymore. Or maybe they were used in history, but today they are not being used.
Sir, please repeat it regularly.
Okay. Do you understand from, I'm starting from VLAN numbering. VLAN numbers maximum what you are supported is a 12-bit. Correct?
Yeah.
Now, what is
Understand.
12-bit is equal to 4096.
Yeah.
Computers calculation always start from 0, or that's why the numbering range starts from 0 and ends up on 4095. Okay. The range what you have is 40. The combination, if you add 4095 plus 0, it goes to 4096. Any use case of reserve VLAN as of today, only from 1002 to 1005, which are basically for some token ring, which is very old. If some companies are using it, I'm not really aware of that. I believe no, I've not heard. Even in my TAC tenure, I haven't heard anyone was using reserve VLANs anywhere. So you can say that the old systems which are not being used anymore. What are standard VLANs? They start from the range of 1 and goes to 1001. And extended VLANs?
1006 to 4095
Yeah.
94.
1006 4094. Yeah, exactly. This is how your range exists. Okay. Any kind of doubts till now with respect to the VLAN numberings? There is nothing much which I can explain in this. Okay. Now coming back to the previous question, what I had raised, let me clean this up. When you power on a switch, it is going to be part of a VLAN 1. So it is going to be part of a single broadcast domain, which is nothing but VLAN 1. We'll quickly power on one of the switch and see what exactly is the behavior. It is getting powered on for the first time, you can say. Now, I will just do show VLAN brief. This command will show you the whole brief table about which are the existing VLANs, what are the VLANs that you have created, default VLANs on all those things. So by default, if you see, all VLANs are part of, see this ports 1, 2, 3, 4, 5, 6, 7, 8. These 8 ports are by default part of which VLAN? VLAN number?
1.
1. Which is
VLAN 1.
the name to that is default VLAN. Now, do you know the interesting fact about default VLAN? So first of all, with Cisco and majority of the vendors, 1 is considered to be the default VLAN. But what is the purpose of having a default VLAN? Is anyone aware about it?
Using for management VLAN.
Not mandatory. You can even use different ports.
By
VLAN
default,
one.
the switch act as a single broadcast domain. So if we do not
Yes.
create the VLANs, so it will be considered as default VLAN. All the interfaces are assigned to the default VLAN.
So, yeah, exactly. They will be part of default VLAN. But what is the use case? Is there any other use case of having VLAN 1?
Yes.
Yeah, what is
The
that?
use of default VLAN is to exchange control packets.
Exactly. Now, what is control packets? How many layer 2 protocols are you aware about? You must have read it in CCNA in your office. Someone talking about it. Layer 2 protocols. In OSI reference model, they always talk about each reference model ideally explains the protocols which they support at individual layers. So what are the layer 2 features? Those are
STP,
supported. Okay.
port channel.
STP, which is port channel in terms of either LACP or PAGP, which are basically port channels, right?
Yeah.
Or ether channel. Anything else?
ATM.
VLANs.
VLANs we have already discussed. Any other thing?
VTP.
VTP, good. More?
TDP, LLDP.
Sir,
Good.
HSRP.
HSRP, ideally layer 3.
ARP.
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 Layer 2.5.
2.5 years. MAC address table.
TDP, MAC address table is not a technology or a protocol. It's just a TCAM or a table.
CDP.
CDP we have covered.
BPDU.
BPDU, it's not a protocol again. It's a representation of STP.
Sir, BGP.
BGP works at layer 4. We are talking about data link layer. Now, you have considered at least 3, 4. Let's talk about it. Okay, BTP. Another one is UDLD, if you remember or if you have read. Now, what is CDP in this? Take an example of CDP. How many of you know what is the full form of CDP?
Cisco Discovery Protocol.
Cisco Discovery Protocol. Is it running by default or we have to configure it?
By default, it will run LLDP. We have to.
Exactly. LLDP we have to manually enable. CDP by default it is running. CDP will help you to find out who is a neighboring device. That is a job of CDP, correct? Now consider 2 switches and you connect them to each other. Now, when you go on, you are not running any kind of command. You have not executed anything. You have not even gone to config mode. Still, when you do show CDP neighbor, it will show you who is the device connected to you, correct?
Yes, correct.
Now, how does switch 1 comes to know what is a port or what is a switch connected to its interface, maybe 0 by 0 and 0 by 0 here on both sides. It is happening via CDP, correct?
Yes.
Now, remember, every port is a part of which VLAN when you power them on?
VLAN 1.
VLAN 1. We have already seen this in like 5 minutes back. Now, what is VLAN 1 already doing? It is also helping you to exchange the CDP information. CDP packets or CDP frames are being sent between switch 1 and switch 2, and that's how they are able to find each other. So ideally, default VLAN, what Jacob said, I believe Jacob is your second name or first name?
Second name, and first name is Lloyd.
Lloyd, my bad. Okay, now what exactly default VLAN is ideally helping you? It is helping you to exchange the control traffic. Understood what exactly default VLAN is doing? It is helping you to exchange the data related to CDP. I'll write down here. CDP, VTP, LACP, PAGP, UDLD, DTP. This is another protocol. Whatever I have, maybe you just use a different color. Yeah, whatever I have marked in yellow, this information related to this is being exchanged between the switches via default VLAN. This is a use case of default VLAN. Is it clear? Or any kind of doubt with this? I can repeat.
Repeat it again.
Yeah. Now, understand this. You understood, right? I'll show you. I'll power on one more switch and I'll show you that it is automatically picking up the information about CDP. It means the neighbor discovery is happening automatically. Correct? Not neighbor discovery, but whoever is connected to you. Is it right? That is the job of CDP. Now, to do that, how does switch 1 comes to know who is connected to it on this interface 0 by 0? Switch 2 is sending some kind of frame through which switch 1 is able to understand who is connected to it. And same way, switch 1 is sending some kind of frame which will ideally help switch 2 to understand or find out who is connected to it on Ethernet 0 by 0. All this information ideally is traversing through default VLAN. So the information related to VTP, CDP, Ether channel, UDLD, DTP is getting exchanged via default VLAN. That is a use case of default VLAN. Sudeep, have you understood it now, or should I explain it again?
Clear, sir.
Nagaraj is clear. I'm expecting answer from Sudeep. I'm not sure if he's understood.
Sir, from my side, this is clear.
Go on.
Yeah.
Understood. Okay. Now,
it's okay. Understood now. Thank you.
perfect. Moving ahead. Now, how many of you are really clear about what exactly how exactly switch learns the MAC address?
Using ARP protocol.
No. ARP is just one way.
Reverse ARP and ARP.
No. What things we are reading in CCNP? This is first day we are talking about VLANs. Pankaj. Okay, I'll go through a brief about switch learning the MAC address. So though even it is covered in CCNA, but let's quickly do it. Okay, don't worry about access, VLANs, anywhere. All those concepts are not what we are talking about now. All we know is PC1 is able to talk to PC2, and we want to find out how switch will learn the MAC address. So let's say this PC ideally creates some kind of packet destined to PC2. So PC1 is having IP address 10.1.1.1/24. PC2 is having IP address 10.1.1.2/24. I will be talking about packet walk or how layer 2 communication ideally happens later on. So as of now, focus is on switches. So it will create a packet for some kind of packet ICMP, TCP, HTTP for 10.1.1.2. PC1 will send it to switch. Okay. When this frame or packet reaches the switch, what switch will do? What is your OSI reference model says? First physical, then data link. Correct?
Yes, sir.
Layer 2 switch ideally would be working at which layer?
Data link.
Good. So we will not move ahead or one layer above, which is network layer. So the movement, step 1, PC1 sends frame on its NIC. NIC means network interface card through which it is connected to the switch. Switch 1 receive it and start the process of decapsulation. How many of you are aware about the process of decapsulation? Again, one more CCNA concept. In one-liner, decapsulation is a process where any of the frame packet, you can say, goes from physical layer till application layer. This process is called as
Encapsulation.
decapsulation. When frame starts or packet starts at application layer and goes to physical layer, that is from layer 7 to layer 1, that is encapsulation process.
Yeah.
Anything from layer 1 to layer 7, it is decapsulation process. So what do I said? Switch 1 receives the frame and starts the decapsulation process.
So at the receiver side, no?
It is on switch, it is happening as of now. We are talking about switch here. Let's say this frame is entering here. Starts decapsulation process. Now, what is the decapsulation process? It means from physical layer, it would be in the form of what do you call it, electrical signal or light wave. It will convert from physical and go to data link layer. Now, data link layer is all about, in today's world, we are using Ethernet, correct? Now in Ethernet, if you have gone through the details of Ethernet header means there is a concept in Ethernet header which is called as FCS. How many of you are aware about this? Again, OSI reference model has spoken about FCS. Anyone? Pramod, can you go on mute?
Frame check sequence.
Yes, frame check sequence. Basically, it validates whether the frame is not corrupt and its integrity being maintained. So first thing what it will do when it will decapsulate the process and goes to data link layer, at data link layer, FCS is checked. If FCS is good, okay, if FCS is good, then only next step will happen. So two conditions, either FCS is good or FCS is bad. So if FCS is good, I'll explain what exactly happens. If FCS is bad, frame will be dropped. It will not do anything else. It will not even bother to check anything else. It will just drop the frame. Now, next situation, if your FCS is good, then it will check the source MAC and destination MAC. Now, before I do that, I'll show you how Ethernet frame looks like. I am expecting many people may not have seen it. I'll just clean it up for time being. And if you see this, it have a frame check sequence, which is nothing but CRC, and it will validate this part first. If everything is good with this part, then it will check for source address. Now, what will happen after checking the source address? Let's go into that. when FCS is checked and you have checked the source entry, now the source MAC address is ideally checked in this switch MAC address table. It is called as MAC address table. So what it will see, let's assume PC1 is having a MAC address of A and PC2 is having a MAC address of B. So it says, is there any entry for MAC address of A? If there is no entry, it will create the entry. And it says, I have learned it through, let's say maybe this interface is 0 by 1. Here also it is 0 by 1. So it will say on my switch 1, if I want to go to MAC address A, I will go on interface 0 by 1. Is it clear till now?
Yes, sir.
Perfect. Now, this is which MAC address it is checking, source MAC or destination MAC?
Source max.
Source MAC. Always keep in mind, the MAC address learning ideally always happens for source MAC. Now, what if entry already existed? What we spoke just now is a creation of new entry. But what if entry already existed? If the entry already existed, that what it will do, there is a concept of aging timer.
Reset the
Ma-
timer.
MAC aging timer is what we call it. By default, that is 300 seconds. What it will do, it will just reset this timer. Okay. If let's say the timer has been reduced to 10 seconds, and if you receive any new frame from PC1 with source MAC address of A, which you are already aware, then you will just reset the timer and make it to 300 again. This is a constant process which ideally happens. Understand what are the two probabilities which will occur?
Yes, sir.
Check entry in MAC and create if needed. Now, next step. Now it has to find out where this frame needs to be sent. Okay. Now this is where what it will do again. It will, because it is a layer 2 switch, it will always refer MAC address table. So it will find out if I want to go to MAC address B, which is written in the frame, I don't know where to go. So what it will do, it will broadcast. Now this is where the VLAN concept gets triggered. Remember, here, consider this being part of VLAN 10. As of now, consider everything to be part of VLAN 10. VLAN 10, 10, 10. And this is also 10. And let's say maybe this switch is having another interface going to another switch here, which is part of VLAN 20. And don't worry about why you have configured VLAN 10 in between switches. That is not that will not work out. I'll explain that concept to you also.
Sir,
Go on.
if the packet is broadcast, will the other ports be able to see it?
Sorry, what are you saying?
If the packet is broadcasted, will the other PCs be able to see it?
In this scenario, if they are part of a one broadcast domain, yes.
Okay. Thank you,
Okay.
sir. Okay.
Now consider this another switch, which is switch 3 is having VLAN 20. So this is where the broadcast concept or VLAN concept is triggered. It is saying, so it will also have one more entry, which I was expecting you to explain later on, but it will always also say that if you want to go to MAC address A, I am learning it through VLAN 10. These are the three entries what you will see in the MAC address table ideally. Okay, one, through which port you are learning it, through which VLAN you are learning it, and what is the MAC address. Three things. Now, what it will do, you are receiving something in VLAN 10 and you want to broadcast it. So what you will do, you will broadcast it in same VLAN. What will happen in general understanding, the broadcast, this specific will be sent to this port. Whatever frame you have received, that will be sent to this port. It will not be sent towards switch 3 because it is a part of different VLAN. That's where the VLAN as a concept is being used. Is everyone clear till now?
Yes, sir.
Yes, sir.
Good. Now, whatever we have spoken has happened at switch 1. Now, I told you this broadcast will ideally come to switch 2. What switch 2 will do? Repeat the whole process, whatever we have seen. Correct? Give me the confirmation. What switch 2 will do? Again, step number 1, this frame which was PC1 had created, it will reach out to switch 2. Switch 2 will do one simplest thing. Switch 2 will
will
again
repeat the
do the
process.
decapsulation process. Yes. Then do the FC. So it will process this thing. So instead of 1, just replace it with 2. So 2 receive it and starts decapsulation process. At data link layer, FCS is checked. If FCS is bad, it will drop it. If FCS is good, it will move to next step, which is check entry in MAC address table. So now consider switch 2's MAC address table is this one. I'm just drawing it here. Okay. Switch 2 MAC address table. Do we have entry for switch PC1's? Do we have PC1's entry into switch 2's MAC address table?
No.
No.
No. So what it will do? It will create the entry. It will say if you want to go to MAC address A and consider this is maybe port number 0 by 0. Okay. On both sides. If you want to go to MAC address A, you have to go to 0 by 0 and you are learning it through VLAN 10. Is it clear till now?
Yes, sir.
Yes, sir.
Now what switch 2 will do? Let's assume switch 2 already knew about PC2's MAC address. So what it knew? That this entry already existed. That if it is for PC, if you want to go to PC2 or with MAC address B, you have to go on 0 by 1 and you are learning it on VLAN 10. So what it did, it just forwarded that frame towards PC2. So have you learned, is a frame or a packet which was originated by PC1 has landed on PC2?
Yes.
Now, has switch learned about the MAC addresses?
Yes, sir.
Yes.
Now,
Yes,
this
sir.
process will get repeated all the time.
Okay, sir.
Any kind of doubts with this?
No, sir.
Everything good?
Yes, sir.
Good. Now, next. Let me again draw the diagram. First of all, the concept what we are going to talk about is this. Now, I have told you this is PC. It is connected to a switch. PC1 is connected to a switch 1. And then you have another PC which is connected to here. That is PC2. Now, I told you it is a part of VLAN 10. Let's assume this it is a part of VLAN 10. So first concept what you have learned today is VLAN. Now, second concept what you have learned is MAC address learning. A third concept what you will hear is access ports and trunk ports. Now, what will happen? Any of the port, yes, B, MOA, it is switch will always learn the MAC address from the source address, not from destination. Now, what will happen? A port which could be between the switch or between the end host to machine and switch can be configured either as a access port or as a trunk port. Okay. Now, what is the major difference between access port and trunk port? And I am expecting good answers.
Access ports pass single VLAN traffic and trunk pass multiple VLAN traffic.
Okay, single VLAN traffic. How trunk is able to pass multiple VLAN traffic?
By tagging. Bottom
Multiple-
tag.
multiple VLAN traffic, and it is achieving this by doing tagging. Now, so it means it will tag individual VLANs, correct?
Sir, what is tagging?
Good question. What is tagging? Now, consider you have understood the concept of VLANs, and I am representing you this diagram, PC3 and PC4. Now, consider PC1 and PC2 are part of VLAN 10.
Yeah.
Here, already written down. And PC3 and PC4 are part of VLAN 20. Correct?
Correct.
Now,
sir.
you have two different VLANs. Now, let's say switch 1 needs to send some data towards switch 2. How it will understand whether that is destined for some machine which is a part of VLAN 10 or some machine which is a part of VLAN 20. There should be some mechanism revolving around it. That mechanism is basically what you call as tagging. So what you do in your Ethernet frame, you add the details about VLAN, that this specific frame is a part of VLAN 10 or VLAN 20. And addition of these VLAN details is called as tagging. Is it understood?
Sir, actually, your
Yes,
voice
sir.
is breaking. So
Is it only is it for everyone?
Yes.
Yes.
No,
Not
it's clear for me.
It's clear for me as well.
Your voice is breaking from my side, sir.
Gaurav, can you hear me clearly? I believe you people are traveling or something, because half of the people are able to hear it properly.
Right now it's clear, sir.
Not sure what is the problem. Just give a
Right
try
now
now.
it's clear, sir.
Okay, just give a try. And if you hear it problem again, I'll try to solve it. Now, who asked me that question? I'm not sure, but have you understood what is a concept of a word called tagging?
Sir, I am asking. Sriman.
Shriman, have you understood?
Yeah. Sir, actually, when you understand,
I can't hear you.
sir, please repeat, sir.
No, your voice was gone. Can you repeat it again? Shriman, can you repeat what is the question?
Sir, actually, sir, what do you mean by tagging, sir?
Yeah.
My
Okay.
question is that.
Okay. So tagging. Just now we took an example that PC1 and PC2 is a part of VLAN 10. Correct?
Yeah, correct, sir.
And PC3 and PC4 is a part of VLAN 20.
Yeah.
Now switch 1 will send some information which ideally will either go to PC2 or will go to PC4. Correct?
Yeah, correct, sir.
Now it has to pass it through same link, same one physical link. Correct?
Okay. Correct, sir.
That's where you have to add the information about VLAN, that this specific Ethernet frame belongs to VLAN 10 or VLAN 20. Right?
Yeah,
This information
right.
needs to be added into Ethernet frame, and
Yeah.
this concept is called as tagging. Tagging of your VLAN information in the Ethernet frame.
Yeah.
Is it understood now?
Yeah, sir, understood.
Okay. Now, coming back to this thing that you are doing a tagging in a trunk port. Now, the question is, are you doing any kind of tagging in access port?
No tagging has been done in
No, sir.
No tagging.
sir.
Yeah. So this is basically not only single VLAN traffic, it is untagged traffic. When I say untagged traffic, it means there is no tagging information. Pramod, hold on, please. I'll explain. Untagged means there is no VLAN data that is being sent on an access port. Okay? VLAN information is always sent on a trunk port. Is this clear till now?
Yeah, clear, sir.
Good. Now let me talk more about trunk. Why it was needed to have a what do you call this concept? I mean, multiple links, or what was the tagging required? Drawing the same topology. Switch 1 is having two machines connected, PC1, PC2. Switch 2 is having PC3, PC4. Now this was a part of VLAN 10 and 10, 20 and 20. Now what would happen? If you want to pass or send some kind of traffic which belongs to VLAN 20, you would add one more link over here, correct? One will belong to VLAN 10. So any kind of traffic originated from VLAN 10 will traverse through VLAN 10 here, and then it will go to destination on VLAN 10 on switch 2. Same way, any traffic originated in VLAN 20 will land on VLAN 20 here, and then it will go to another link or another on the remote side or on the destination. Now tell me, if you are having maybe 10 VLANs on the left side and 10 machines which are part of one VLAN each, and same situation on the right side, how many physical cables will you add between the switches?
10.
10. Was that a scalable solution?
No, sir. No, sir.
No. So what you had to do, you had to bring on some concept which ideally will send a data via same link, but it will be able to differentiate that this specific data belongs to which VLAN. That's where the trunk concept was introduced. Clear? What
Yes, sir.
trunk will help you to do? It will help you to do tagging of VLAN information, in simple words. Is it clear till now?
Yes, sir.
Yes, sir.
Now,
Yes, sir, clear.
where exactly will you use trunk and where exactly will you use access? Ideally, your machines, which is basically PC, printer, CCTV, IoT devices, maybe, I won't say access points or wireless would be conditional, routers, even firewalls. These many probabilities. Everyone have a different understanding level. So if your PC don't even understand the concept of VLAN, would you send any kind of tagged traffic towards PC? So let's say this is your switch connected to a machine. Does your PC understands the concept of VLAN tagging, or does it understand the concept of VLAN in simple words?
No.
No. So if your PC don't understand the concept of VLAN, will you send any kind of information about VLAN to PC?
No.
No. So if you won't send the information, what kind of port will you configure here?
Access port.
Good. What about printer?
Access port.
I'll use the short forms. A is access, T as trunk. CCTV?
Same.
Access port. IoT, I'll skip. Now access point, maybe wireless. May understand it, may not understand it. So it is conditional. It can be access or it can be trunk. Same way for routers, firewalls, and wireless world. You can configure it as a access or trunk. Now, if you have another switch 2, will you configure this as an access or will you configure this as a trunk?
Trunk.
Can you configure it as an access?
No.
No, sir.
And if we are using a single VLAN, we can.
Good one. Who said this?
It's Kiran here.
Good. See, this is where the perspective comes in. What if your topology only have one machine? So this is switch 1, this is switch 2. It is having a server maybe, okay, who is a part of VLAN 10 here, and this is a part of what do you call it, client, and there is some data transfer happening between these two, and there is no other machine which is a part of this diagram or the topology what I have shown you. Now, can you, and this is going to be access, we are already aware about this. Now, can I configure access in between switch 1 and switch 2? Just look at the topology, don't consider the future aspect. We may add one more, or we may add one more VLAN into it, or one more machine into it. Don't go into that. Just look at the topology and tell me, is it mandatory that I should configure a trunk between switch 1 and switch 2? Then only client will talk to server. Or even if I configure access, the communication will work.
Even if you configure it as access, the communication will work, because when you configure it as access, there is no tagging.
That is the
So-
only difference. That is the only difference. There will be no tagging, correct? But the communication will still work. How many people do agree with this?
Yes,
Yes,
it will work.
I agree, sir.
So have you understood? Is it not? It is not mandatory that you have to configure the trunk.
Yes.
It totally
Yes, sir.
depends on situation. Is it clear?
Yes, sir.
Good. Now it totally depends on what situation or what is the demand of your setup. It totally depends on that. It is up to you how you want to design it. That is the design aspect. We will not talk about it. Any kind of doubts till now?
No.
No, sir.
No, sir.
Okay. Last topic, access and trunk. I believe you are clear. I'm going to represent your topology and you have to tell me the answer about it. Just use your mind, whatever you have learned till now, till in last 1 hour, and tell me logically what would be the answer. This is my switch 1 connected to switch 2. This is my PC1. The IP what I have configured on PC1 is 10.1.1.1/24. On my PC2, the IP configured is 10.1.1.2/24. This is a part of access. A means access, and it is a part of VLAN 10. This is a part of access, and it is a part of VLAN 10. Switch to this interface is a part of access, and it is a part of VLAN 20. Switch to this interface is a part of access, and is a part of VLAN 20. Now the question is, will PC1 talk to PC2?
No.
No, sir. No, sir.
No, sir.
Anyone?
PC1 will talk with PC2.
Yes.
Just one. Okay. Now this is where you have to rewire your brain, because now whatever you have read versus whatever you implement the logics that you have learned in last 1 hour.
So PC1 is having VLAN 10, and switch 1, the connection between switch 1 and switch 2 is defined as access. When access is defined, it will not tag anything. It is untagged.
Exactly.
So whatever traffic which has been sent on VLAN 10, the switch will identify as no tag, and it will transfer the traffic towards switch 2, and that will be received by PC.